Thanks for joining us in this final segment, where Yankin and I will wrap up our discussion on automotive chip design with how the combination of safety and security is becoming a critical design criteria. Can you describe what a safety manager is and the role it plays in an automotive SoC?
Safety manager is the critical brain which monitors and manages system failures and real-time faults within the system of chip. And this meets or helps you to meet the highest level of the ISO 26262 safety standards, especially ASIL D, and it's generally implemented as a two-processor core operating in lockstep, mostly with a small shift to avoid a potential huge fault happening in the same area, and comparing those results to detect the occurrence of an error condition. Synopsys ARC functional safety processors are, as you know, are certified for ASIL B and ASIL D operation. Right. And we are seeing increasing usage of our processors as the chip's safety manager, which is one of our specialties, I would say. We are also providing software that our customers use for functional safety bring up and management of safety escalations and prioritization of these safety events to give them additional flexibility in their implementation and reduce development effort.
Okay, and that's important, right? Because what's interesting is at the same time that more and more of this automation is going into cars are increasingly connected, right? So they're collecting and transmitting valuable information, which makes them vulnerable to security attacks. And obviously a car can't be safe if it can be easily hacked. So safety and security are going to be inseparably linked requirements in automotive going forward. How do you see security being addressed in automotive chips?
Yeah, security. I mean, isn't that funny that languages like German, my native, or Chinese, security and safety are the same word. In English, we have this separation, but nevertheless, the fact is security is paramount to address, and it needs to be approached together with safety more holistically today. And SoC is safe when it is secure, and secure when it's safe. As simple as that. Secure systems must be able to handle malicious attacks that can occur unpredictably during the lifetime of a system. Designing high-grade security into automotive SoCs can be done in a variety of ways. One of the most robust methods is implementing chips with integrated hardware secure modules, HSMs, and a standalone hardware root of trust that this is the one which provides the prevention of random and systematic faults, as well as it helps you to fend malicious attacks. So HSMs, especially safe HSMs, will play a more and more role in all complex automotive SoCs in the future.
Well, the auto industry is clearly undergoing a big transformation, right, to develop both smarter and safer cars at the same time. And that's going to impact the entire supply chain, from the silicon IP blocks that we offer all the way up to the assembled vehicles themselves. It's truly an exciting time to be at the heart of these new electronics. Thanks for your insights, Yankin, and thank all of you for watching.